Okay, let's go to page 226 and start with number 322. Okay, so you have, so basically you have the floor. Okay, let's draw a big picture. So you have a floor, and you have the wall, and you have a large ball is tangent to both of them. And you're looking for the biggest ball that can roll through here and tangent to all three. Okay. Okay, so basically you have this situation. Okay, so this have the radius up. Let's go and call it big R. This is big R. So this is also R, and let's go and call this small r. Okay, so this is small r, small r, small r. Okay, so by looking at the diagonal, so this whole diagonal is, so this is also r, right? Transfer, right? So this diagonal would be square root of 2 times r, right? Because it's a 45-45 triangle, and this is equal to this r plus this small r plus this part over here, which is a square root of 2r. Right? Again, this over here is square root of 2r. Okay, so now you just have to solve. Go ahead and minus r on both sides. So you have square root of 2r minus r equal to square root of 2r plus r. And I'm going to flip this over, okay, because we're solving for small r. So from here you have to do the factoring. So factor the r, factor the big R, factor the big R, so you got square root of 2 minus 1. There we go. Okay, then you have to divide. So small r equal to big R, square root of 2 minus 1 over square root of 2 plus 1. Okay. And then you simplify, so times by conjugate. So small r will equal to big R. So on the bottom, you're going to get 2 minus 1. On the top, you multiply, you're going to times by 2 minus square root of 2 minus square root of 2 plus 1. So small r will equal to r times by, so this is equal to 1, so it would be 3 minus 2 square root of 2. And that's it. Okay, let's go to 323. One thing will be helpful when you're doing this kind of problem is, draw a big nice picture so you can see it clearly. Okay, so 323, the picture is given. So you have a cone, and the radius is 16, and the height, obviously this is not drawn to scale, and this is 96. Okay, and what is the height in feet of water in the tank if the amount of water is 25% of tank's capacity? Okay, so you're looking for the height, okay, if this is 1/4. Okay, since the ratio, since this is 1/4 of that, so the volume ratio for volume ratio of this to this is equal to 1/4. The small to big is 25%, right? So 25%. so again, this is 25%. Okay, so this is 25%. So it's 1 over 4. So what you can do is from the volume, instead of trying to figure out the height and the radius, you don't have to do that. Okay, so what you can do is you can figure out the volume times by 1/4, and then you can figure out the height from there. But it's too messy. It's a lot easier if you use the scale factor. So volume ratio. Okay, volume ratio is 1 over 4. So the scale factor will be cube of that, the cube root of that. Right? So again, from volume, it's 3-dimensional, to scale factor, the 1 dimension, you have to take the cube root, right? So the scale factor will equal to 1 over cube root of 4. And therefore the height, so this will have the scale factor of that. So the height will equal to the 96 times the scale factor. Okay. Now to simplify this, we need to multiply by cube root of 2. So the height will equal to 96 cube root of 2 over 2. And you simplify, so the h will equal to 48 cube root of 2. So you don't even need to bother to figure out the volume at all. Okay, just use a scale factor, it's a lot easier. Okay. Let's go to 324. Okay, so this is a truncated icosahedron. It's a polyhedron with 32 faces. Okay, and 60 vertices. And 90 edges. Some of the faces are pentagons and some are hexagons. Exactly 2, so you got 2 hexagons. And a pentagon. Meet to join each vertex of a polyhedron. Okay, so again you got hexagon, hexagon, pentagon to join to make a point. Okay, so how many faces of the solid are hexagons? Okay, so what we need to do is, just like the one we did earlier about about how many vertices and how many corners. Okay, so what you do if you think about doing it individually. Okay, so what you do is, since we're looking for a number of hexagons, so what you do is let x equal to number of hexagons. Okay, and therefore 32 minus x will equal to number of pentagons. Okay. Now let's consider edges. Okay. So the total number of edges. Okay. Equal to, so let's go and consider each one individually. So hexagon. So there are six edges for each hexagon, and there are x number of it, so times by x. Okay. Plus for the pentagon, each one has 5 edges, and there are 32 minus x for that. Okay. But notice that each edge is counted twice. Like this edge over here is counted by this hexagon and by this pentagon. This edge over here is counted by this and this. This edge is counted by this and this. So every edge is counted by 2 polygons. So each edge is counted twice. So you have to divide by 2. Okay. Okay. And now we can substitute. There are 90 of them. There are 90 edges. And you got 6x plus 160 minus 5x over 2. Cross multiply. So you got 180 equal to x plus 160. So minus 160 minus 160. So x equal to 20, and that's it. Okay, so there are 20 hexagons. Okay, again, sum up. Say, look at number of edges, right? So each hexagon has 6 edges, and there are x number of it, so times by x, right, times number. For pentagon, yeah, each pentagon has 5 edges, and there are this many, so 5 times that. So to give total number of edges, okay? And this is if they are separated, but because they are jointed, every edge got counted twice, because every edge is formed by, it got counted by this and this. This edge is counted by this and this. So you have to divide by 2, because every edge is counted twice, okay? And these edges are giving as a total of 90, so put 90 in here and you solve, and that's it. So whenever you deal with this kind of problem, you kind of have to count each one, count whatever you're looking for separately, and then you see how many times you got counted. You got counted how many times over that. Okay, and you have to divide. Okay, let's go to 325. So you got A, B, C, D. Okay, so 325. So this is a regular tetrahedron. Regular tetrahedron means that every face is a equilateral triangle. Okay, so each of these would be 6. Okay. Now, because this is a equilateral triangle, look at the base. Look at the base ACD. Okay, so if you connect their median, they're going to meet in a point called a centroid O. Okay, and so if you and this would divide the median into ratio of 1 to 2, right? So if this edge is 6, okay, if this is 6, this would be a 3, this would be a 3, okay? And this is, again, this is an equilateral triangle, so this half over here would be the 30-60 spatial triangle. Okay, so if this is 3, this would be 3 square root of 3, okay? And again, it divides into 1 and 2, right? So this would be square root of 3, and this would be 2 square root of 3. Okay? Again, this would divide into ratio. This would be 1/3, it would be 2/3, ratio 1 to 2, right? Okay, so 1/3 of that is that, and then twice that, okay? So once you got all your dimensions, then you can go and look at your triangle BOD, okay? So BD is 6, and BO is what you're looking for. You're looking for the distance from B to the face. That means the altitude, right? And this over here would be 2 square root of 3, right? Again, this is the longer part, right? And this would be, so 3 square root of 3 is this whole thing, okay? And square root of 3 is this part of here. So I'm going to get rid of that 3 to make things less confusing. Okay, so now we can figure out the h, right? So h square plus 2 square root of 3 square will equal to 6 square. So h square plus 12 equal to 36. H square equal to 24. So h equal to square root of 24. So h equal to 2 square root of 6, and that's it. Okay, so again, you got to able to kind of able to visualize the regular tetrahedron, and also you have to realize that this is the base is the equilateral triangle, and you draw the medians. They will meet in one point that is called a centroid, and you would divide the median into ratio of 1 to 2, or make this 1/3, this is 2/3. Okay, and from there you can figure out this, and you can figure out the parts that you need for the triangle. Okay, let's go to 326. Okay, so this one you're going to fit 9 balls into a cube. So basically you're going to have one at each corner, and you're gonna have 1 in the middle, okay? So if you look at two-dimensional, you're gonna have something like that, and you're gonna have 1 right in the middle, right over here. So you kind of have to able to look at the diagonal, okay? So if you kind of look at it diagonally, so I'm kind of looking at kind of in a way two-dimensional, but this is the top, middle, and the bottom sphere, okay? So the diagonal of the cube, okay, so each of these is 1, right? So if you do two-dimensional, this would be square root of 2, but when you do three-dimensional, the diagonal of the cube would be square root of 3 times the side, okay? And that diagonal, if you look over here, okay, so this is the r, so this would be square root of 2r, and this would be r. So again, this is r. So now you have to be careful. Remember, there's a little space over here, so this would be square root of 2r. Okay. Okay, so the diagonal is equal to square root of 3, and it's going to be equal to square root of 2r plus this r plus this over here, that's 2r plus this r plus square root of 2r. Okay, so you have to be able to visualize what's going on with these. Okay, so you have square root of 3 equal to, combine the like terms, you got 4r plus 2 square root of this would be, well, this is this is three-dimensional, so it'd be 3. So it'd be square root of 3. Okay, because it's three-dimensional, right? This corner over here, so it'd be, so would be the length square plus width squared plus height squared. So it'd be, again, three-dimensional. So when you have three-dimensional, right, so to do the diagonal, you have to go 1. So you're going to have 1 square. So the diagonal equal to square root of 1 square plus 1 square plus 1 square. So that's why you go to square root of 3. Okay, the same thing over here. Okay, so again, two-dimensional is square root of 2 times r, but three-dimensional would be square root of 3 times r. Okay, so it would be square root of 3. Okay. Okay, so you can combine your like terms and this. Okay. So now you have to do the factoring, factor the r. So you got 4 plus 2 square root of 3. And you divide. And I'm going to flip the side. So r equal to square root of 3 divided by 4 plus 2 square root of 3. To simplify, times by conjugate. So r equal to, okay, let's do the bottom first. You're going to get 16 minus, so this would be a 3, and this would be a 4. So 3 times 4 give you 12. On the top, you go and distribute. So you got 4 square root of 3 minus, so again, this will give you 3. So 3 times 2 would be 6. So r will equal to 4 square root of 3 minus 6 over 4. And go and simplify, so r equal to 2 square root of 3 minus 3 over 2, right? Reduced by 2. And that's it. Okay, let's go to 327. Okay, so you have a cone. With radius of 6 and the height of 6, and you cut so that you end up with a cone this much on the top, and you're gonna get this one on the bottom. Okay, so you cut the plane parallel to the base and 2 units away from the base. So this is 2. So that means this would be a 4. Okay. Now, by similarity, okay, so if they are the same, this would be a same, so this would be a 4. So to figure out this volume, you have to use this minus that. Okay. So the volume would be, okay, so it would be pi r squared times h. So pi r squared times h times 1/3. Okay. So that is this one here. Minus, now, so this minus will give you this, right? So this one would be against pi r squared times h times 1/3. Okay, so volume will equal to 72 pi minus, let's just go and factor the pi over 3. Okay, factor the pi over 3, then we can deal with this part over here. Okay, so, okay. So we get 216 minus 64. Okay, there you go. That's much quicker than try to work it out, right? So you can factor the pi over 3, then you can do that. So you're going to get, okay, so you're going to get 152 pi over 3. Okay, let's go to 328. Okay, so you have this picture giving. And this is point A. Oh, the picture is kind of wrong. I've got to redraw this one. Okay, redraw. Okay, what I did is I have the backward. I have the front, line up, whereas the back is supposed to line up. Okay, there we go. And this point is okay, so we got that. Okay, so the cube, okay, so this is 1, and this is 2, this is 3. So if you just look at the picture from the back, so you got A, C, B. Okay, so so again, this is a square, so 3 3s. This will give you 3 squared root of 2. So this is 3 squared root of 2. And this is 6. Okay, so we can figure out the AB. Okay, so use the Pythagorean Theorem. So AB squared equal to 6 squared plus 3 squared of 2 squared. So AB squared equal to 36 plus 18 So AB square equal to 54, and take the square root. So AB equal to square root of 54. So AB equal to 3 square root of 6. And now you have to use a ratio. Okay, so the length that you need, so this kind of divide into, okay, so that's your 1, so that's your 1, 2, 3, right? So again, using the proportion, so this is 3 square root of 6, right? So the length, let's call this L. So the length would be 2 out of 6, right? So it'd be 3 square root of 6 times 2 out of 6. Right? Because again, if you look at 2 out of 6. And so if you simplify, you get square root of 6. So this length over here, just this part over here, okay, would be equal to square root of 6. So again, square root of 6 is just this part right over here.